Hello, welcome to this session of OpenMentor.net. In this session, we are going to talk about C programming language with mathematical functions. Right now, I have defined two variables, int and float. I have got the variable I. In this, I'm going to store number 5, okay? And then I'm printing it as decimal. There is no problem. But you can give octal numbers and hexadecimal numbers. 5 is a decimal number whose base is 10. Decimal number means base 10. Same way we can use octal numbers, base is 8. Hexadecimal, base is 16. Let me assign an octal number. How to assign an octal number? The first digit must be 0. If the first digit is set as 0, it denotes that it's an octal number. Now I say 37. Now let me compile. This is an octal number 37, but I am printing it in decimal. Okay. So let me execute. Once I execute, it says 31. 31 to the base 10 is a decimal equivalent of 37 in octal. So 0 means octal. 0 prefix octal. The same way, if I give, how do I counter check? Now I assign 31 as a decimal number without the 0 prefix. Now I want to print it as octal, %O. Let me execute. Now you see 37. So the octal number 37 is equivalent of decimal number 31. It's the first thing in terms of the number system. Now if I want to have hexadecimal, okay, now 0x, if you put 0x and then say 15 or say 25, okay, and then I print it in %decimal. Let us see. F9. Okay, there's a problem in that prefix. So the problem that I had was, it was O. I should have typed 0. So you need to be careful when you are typing the digits, though there's a slight variation the way 0 and O look. Okay, so if you have 0 and X as a prefix, this denotes a hexadecimal number. Okay, 0x means hexadecimal. So I'm printing it on decimal mode. So what is the equivalent of hexadecimal 25? Now if I do that, the decimal number 37 is equivalent to the hexadecimal 25. In hexadecimal, you also have digits or the alphabets A to F. A stands for 10, F stands for 15. Now let me see what is the equivalent of this. So FF in hexadecimal means 255 in decimal. So you can use octals or hexadecimals in C programming. So I want to prove this again. 255, I give it over here. I want to print it in hexadecimal. Okay, so let me compile. It prints FF. So the decimal equivalent of FF is 255. So this way you can verify back. So if you have 0 as a prefix, it's octal. 0x as a prefix, it's hexadecimal. Same way you can use those %O or %0x in the printf statements for the format of printing it. Now we are going to see a few mathematical functions. Before that, I want to accept, so far we have accepted integers and characters from the user input. Now I want to accept scanf %f, okay, for the variable f1. So I get the input from the user, then I print that particular thing %f \n f1. Okay, so let me, so far we have used %d or %s to get the characters from the users. Now I'm getting a floating point number, which is a single precision floating point. Now let me execute it. It's waiting for my input. I enter 123.456. I enter. Okay, it prints that particular thing. Okay, I made a small mistake in that one. I should have used ampersand before any scanf. So since I have not given the ampersand, it was having some issues, so I fixed that. Now I have given ampersand F1 to accept that. Now you just watch what happens. I execute this. I'm entering 123.467 and it is printing 123.467003. I have not given 003, but it is taking that. So this is a typical problem in floating point numbers. So in floating point numbers, especially, it is internally stored in some way. So as long as you are okay with some precision, you need to be very careful. So let me do something like this. I say print 4 digits, up to 4 digits in the mantissa portion or the integer portion, and then print only 3 digits in the decimal part. So how does it execute? Now let us execute this. Now let me give 123.467. It is printing that same thing, 123.467. So when the root cause of all these things, though you have entered some value, the way it is internally stored is different. So you need to be careful. Up to the digits that you have given, it may be having the same value, but beyond that, it may store some other value. So you need to be very, very careful when you are dealing with floating point numbers. So you should be very careful with the number of decimal points you look for. Beyond that decimal point, it may have stored the same value or it might not have stored. It is definitely not guaranteed that all the suffixing characters in the decimal point will be zeros. It need not be, as you have seen. Okay. Now, let me show you a few mathematical functions. So I have got the floating point number from the user. Now I want to print, okay, percentage f \n. Can I get the e power something, okay, exp to the power of f1. Okay, let us try this one. What happens? Now let me execute. It is asking for something. I give 1.2. It is printing 3.320 something. What does it mean? I have used a mathematical function called exp. You know e? The e factor e is nothing but 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial. It's a series. So e power something, that is given as exp. This is an internal mathematical function. The same way you can also use something like logarithmic functions. Log of f1. Again, when you simply say log, it means log to the base e. Now let me execute this. I'm going to give 3.2. So log of 3.2 to the base e is 1.163151. The same thing if you want to execute for sine, cos, tan, right? You have all the trigonometric functions. Again, if you want to have log to the base 10, you have to say log 10 of f1, execute. Now let me give out the number 1.2. Log to the base 10 of 1.2 is this. Don't ask me how this number came. You can verify in Clark's table, logarithmic tables. Suppose if you want sine or tan or arctan or any trigonometric functions, that's also available. Simply use this sin, okay, sine of f1. Now let me say f9. Okay, so sorry, it was executing a different function, so I should have used this one. Okay, now let me use this one, compile. Let me give 1.2. Sine of 1.2 is 0.93. Now I want to get the ceiling and floor of a particular number. Just watch. I use this function called the ceil, okay, of f1. Now let us execute this. I give 1.46. The ceiling of this is 2. Let me execute another function called floor. Okay, f9. 1.46. The floor is 1. The ceil gives you the next higher number integer. The floor gives the lower part of that integer. So if I want to have something like the square root, okay, square root, you can use sqrt as a function. Now let me give square root of 4.0. It's giving 2.0. You and I know 2 is the square root of 4. So how do I get the square? You don't have a function. Instead, you have to use a function called POW. POW of f1, comma 3. Okay. So if I use the POW, let me give number 2.0. 2 power 3 is 2 into 2 into 2. It is 8. So these are all the mathematical functions. There are a lot other mathematical functions you have in C. So you need to include math.h. In this we have seen octal hexadecimal equivalents, and then how to get them, and then how to print them, and what is the format specifiers, and some of the mathematical functions like sine, exp, log, log to the base 10, square root, ceiling, floor.